Hello everybody and welcome back. In this lecture we learn about generator expressions. Generator expressions are very similar to list comprehensions. The only difference is that generator expressions produce one item at a time compared to list comprehensions which produce the entire list at once. So for this reason, generator expressions are very efficient in terms of memory, since they don't occupy the entire memory. So let's look at the syntax for generator expressions. So it looks like this. So everything is enclosed in parentheses. So we start out with our expression, and then we have our for statement for, let's say, x in it could be some data type, it could be a list or something. So for x in some object if, and then we have our condition. So this is the general syntax for general expressions compared to list comprehensions. For list comprehensions, we enclose our syntax and expression inside rectangular braces. That's the key difference between generator expressions and list comprehensions in terms of syntax. As I mentioned, generator expressions, they use less memory. Right? That's because they give us the result one by one, one at a time. Let's look at an example. Let's say we have a list containing the following numbers: 2, 4, 6, 8, and 10. What we'll do is, let's say we want to square all of these numbers. So by using list comprehension, we could do it as follows. We can say, let's say, num squared, right? So all this number squared for num in list 1. So this is how we will do it using list comprehensions, and this will give us the numbers squared, right? All the results at once. And imagine if our list is a lot. By a lot I mean, let's say all the even numbers from 0 to a million maybe. So using list comprehensions, it will print out the result for all those numbers. How about generator expressions? Let's see what we will get using generator expressions. So using generator expressions, it will look like this. It would be num squared for num in list 1. So it's the same as list comprehensions, except the syntax is enclosed in parentheses versus rectangular braces in terms of list comprehensions. So when we run this generator expression, we get a generator object. So it doesn't initially return the result. We get a generator object out of this generator expression and its location in memory. So let's save this in some variable. Let's say x. So calling x produces a generator object, and then to get the result we have to call the next function. We have seen the next function, right? So calling the next function on this generator object will produce the first result. In this case, it will square our first number and give us 4. So we get 4. And then to get the next result, we have to call the next function again. And that will give us 4 squared, which is 16. So x.next will give us 16. You see, this reason makes it memory efficient. It gives you the result one at a time. So x.next will give us 6 squared, and x.next will give us 8 squared, 64, and finally we'll get 100, right? The last element squared. Now that we have gotten all our results one at a time, if we call the next method or function again, we get a stop iteration error. That means all of our results are yielded. And if we want to run our generator expression again, we have to first generate a generator object. So basically we have to run this generator expression, right? And then call the next function from this on this generator object. So save it in some variable. It could be the same variable or a different variable, and then call the next function on it. Great. Let's look at another example. Let's say we have a list and save it in a variable called list2, and we'll have some negative and positive numbers. Let's say -3, -2, -1, 3, and 5. So what we'll do is we'll use list comprehension to give us the absolute value of each of the numbers if the numbers are negative, or we'll square or cube the numbers if the numbers in our list are positive. Let's do that. So using list comprehensions, we can say absolute value of the number if the number is less than 0, right? Else, let's cube our numbers if they are positive. So number cubed for number in our list 2. So num means, for each of the elements in our list, or for each of the numbers. So absolute value of, give us the absolute value of the number if the number is less than 0. It means if the number is negative, or else cube the number in our list 2. So this is by using list comprehension. So if we run it, we get a list of all the results. Now let's do the same using generator expressions. So the syntax is the same, except we enclose everything in parentheses. Now running this generator expression will produce a generator object, and let's save this in some variable, let's say y, and then we can call the next function on y, and that will give us the first result, which is 3 since it's a negative number. Calling the next function again will give us 2 since that -2 is also a negative number. So absolute value of -2 is 2. Let's call the next function again. That will give us 1. y.next. The next element is 3, so it will cube that number. 3 cubed is 27. And finally we have 5 cubed, which is 125. Now that we have gotten all our results one at a time, calling the next function will give us a stop iteration error. Let's look at another example of how we can use generator expressions in strings. Let's say we have a sentence and we want to divide or split that sentence wherever there's a space. Let's see how we can do that. You can say word for word in, and then we'll provide the sentence. This is a generator expression. Let's say that's our sentence, and we want to split this wherever there's a space. So what we'll do is we'll apply the split method on our sentence. Okay, and let's enclose everything in parentheses, so making this a generator expression. So running this will give us a generator object, and we can save this in some variable. Let's say ss. Now if we call the next function on our generator object ss, we'll get the first word, right? Since the split method will split the string wherever there's a space. Then this will give us word for word in our sentence. So the first word we'll get is this. So we got our string this. Calling the next function will give us, what's the next word? Is. And then we'll get, calling the next function will give us a, and then generator, and finally expression. So we got a, and then generator, and finally we got expression. So calling the next function one more time will give us the stop iteration exception. Okay, so that's how we can use generator expressions. We can also use generator expressions inside of functions. For instance, let's take our list1 object. Let me call my list1 object. So our list1 contains the elements or numbers 2, 4, 6, 8, and 10. What if I want to find out the sum of all these numbers after I cube them or square them? How can we do that? So we can say, let's see, we can say our numbers cubed, right, for number in list1. So this generator expression will give us each of the numbers cubed, right? And once we have that, we can directly apply the sum function. So we can pass the sum function in our generator expressions. And in this case, we don't need any additional parentheses. Okay, so if we run this, we get 1800. So to check that, number cubed, each of the numbers cubed. So 10 cubed is what? 1000. So at least we have 1000. And 8 cubed is 64 times 8. That probably looks like the same, right? The easiest way to check will be, let me just calculate the sum of our list without, just as it is, and that should give us 18 plus 6, 24, 28, 30. So we got 30, and if we square the numbers and calculate the sum, let's see, we can easily calculate this. 10 times squared is 100, 8 squared is 64, that's 164 plus 36, That's 200. 200 plus 4 times 4 is 16. 216 plus 4, 220. So that looks fine. So that's a simple example of how we can use a generator expression inside functions. Okay, just to summarize what we learned about generator expressions, we mentioned that the generator expression syntax is similar to lists, except we enclose everything in parentheses, and generator expressions use way less memory since they give us the result one at a time, versus list comprehensions, which produces the entire list at once. For this reason, generator expressions are much more memory efficient. And generator expressions, as we have seen in these examples, return a generator object initially, and we have to call the next function to get the result one at a time. Great. Thank you, everyone.